Alrighty, here we go. Lagrange error bound. So I haven't made copies of these notes yet for you guys, so I'm gonna have to write on something on top of this because I just finished making these up on my ownsies. All right, so Lagrange error bound, it shows how, I have Hangman ready to go for you, shows how Blake-Taylor approximation is. So the word that fills in that blank is the word accurate. A-C-C-U-R-A-T-E. How accurate the Taylor approximation is. So this is one where they will tell you when they want you to use Lagrange error bound. It looks bad. Ready? Dun, 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 dun. There's the formula. I know that looks awful, so awful. I think that's why I've been afraid to teach it all these years. But here we go. P sub n of x is the notation for the Taylor polynomial series. So P is polynomial, n is if they want like the third, 3 terms or 4 terms or 5 terms. Minus f of x is the original. So the absolute value of that is less than or equal to this stuff. So here's the main thing. If they are talking about the 4th degree polynomial, then when you look for the approximation, you bump it up 1. So this is a 4 for 4th degree, or 4th degree, then this is going to be 4 plus 1. So you're going to be using f to the 5th, meaning the 5th derivative of x, all over 5 factorial, and then x minus whatever the center is to the 5th. So that's the main thing about Lagrange. Looking at whatever this is, let's say this is the 3rd, then this is going to be f to the 4th derivative over 4 factorial, and this will be raised to the 4th. So you look at the next term. That's what you look at, okay? So here's example 1. It says, let f be a function with 5 derivatives on the interval from 2 to 3. Assume that the 5th derivative of x, the absolute value of that is less than 0.2 for all x in the interval 2 to 3, and that a 4th degree, 4th degree Taylor polynomial, that's this part, for f at the center c equals 2 is used to estimate f of 3. Okay, that's the information given. Here is part A. Part A says, how accurate is the approximation? Give 3 decimal places. Okay, so we're going to practice plugging in to this bad boy up here. Okay, so I'm writing it on another piece of paper because I don't want to mess these up since I haven't copied them yet. So I'm looking at this. This is going to be the polynomial, and it says the 4th degree. So P with a little subscript 4 of x minus f of x. That's really just notation. You don't really do anything with that. Is less than or equal to. So now I'm plugging in up here. So if that is, since n is a 4, this is going to be f to the 5th derivative of x over the 5 factorial. And then we have x minus the center. So remember they said at c equals 2, so that's going to be x minus 2 with, raised to the 5th power. I almost missed it. So if this is a 4, these are to the 5th. These are all 5z's over here. Okay, now we're going to plug in what they asked us. They said f of 3 at x equals 2. Right, that's what they wanted. So our error for Lagrange is going to be less than or equal to f, the 5th derivative of x is Remember right here, they said the fifth derivative of x is less than 0.2. So I know it says less than 0.2, but we're going to go ahead and just use 0.2 because that's the only piece of information we have. So we know it's going to be less than or equal to that, 0.2. So I'm plugging in there. Over 5 factorial. I don't need the absolute value because it's already positive. And then instead of x minus 2 to the fifth, we're going to plug in the 3 for x. So we're going to plug that in. And there's different ways that you can figure this part out. I'm going to put less than or equal to error. 0.2, since there's decimals and fractions, I don't like to mix those. I'm going to change 0.2. I'm going to think of it as 2 over 10. And 2 over 10, because that's the tenths place, would reduce to 1/5. So we would really have 1/5, that represents the 0.2. And then we would have that 5 factorial on the bottom also. And this would be just 1 to the 5th, which is just a 1. My son's VR is buzzing next to me, bugging me. So this is going to be less than or equal to 1 over 5. 5 factorial is 120, which I just happen to know, which is 120 times 5 is 600. And 1 over 600, if they're going to give you a decimal, you can either leave it as a fraction or that would be perfectly acceptable. If you had a calculator, that would be the same thing as 0.002. So how accurate is the approximation? Give 3 decimal places. Oh, because it says decimal places, that's why I went to decimals. So that's how accurate it was for part A. Okay, part B. Part B says, suppose that the fourth polynomial, or the degree 4 polynomial at x equals 3 is 1.763. Use your answer in part A that we just got to find the interval in which f of 3 must reside. That sounds complicated, but it's really not. So we want P4 of 3. And remember that we're doing the approximation. So it's like up here where we have the absolute value of that minus f of x. That's really annoying me right now. So we want the value of f of 3, and so we know that P4 of 3 is 1.763. So that means that all we're going to do is we're going to take that amount, and we got from part A we had 0.002. So we want that f of x, in this case f of 3, in between what it is going to be on either side, the low side and the high side. So we're coming off of the 1.763 on both sides. And then we want that 0.002 that we got from part A, that's the approximation piece. We're going to, on the right side, we're going to add it because it could be that much off on this end, on the high end, and on the other end, it could be that much below it. So this is the approximation that we got from part A. This is the amount they gave us for this piece, and our f of 3 is in the middle. So we're saying what it's going to end up in between, the interval in between. So this case we would get to use a calculator or not, depending on what they give us. So 1.763 minus 0.002 is 1.761. And 1.763 plus 0.002 is 1.765. So that is the interval for part B that it would have to be in between. Part C asks, could f of 3 equal 1.778? Why or why not? So we're going to look at our interval. 1.778 is higher than this, right? But 1.778 is higher than this. This is the highest it can be in our interval. So 1.778 is outside the interval. The number for here has to land in between these. That's all you got. So 1.762, 1.763, 1.764, those are the only options. So this would be no, because 1.778 lies outside of the interval. That's all you'd have to say.